Hi, this is the first part lecture video for chapter 10, the waiting line problems. And the chapter 10 has been divided into four parts. The first two parts, the waiting line problems and the queue system, are the conceptual parts. They include all the details you need, the basic and the fundamental concepts you need to understand and need to know before you start to select the models to help you to solve the waiting line problems. And the third part, we will introduce one of the models. The last part talks about simulating. So actually most of the waiting line problems currently we use some software and other system to help us to figure out. So the simulating is one of them. And this is the last two parts focuses on for this chapter. So now let's talk about the first. What is waiting line problems? What we really talks about for the chapter 10, when we discuss waitings in process. Briefly speaking, the waiting line problem is kind of a problem we need to know how to manage the waiting time in many service settings as well as some manufacturing settings. And if you want to reduce the waiting time, it's actually a trade-off the money costing. So we can imagine that the scenarios if you want to open one more line for checking out in grocery store, so probably you need to hire more people to conduct that task. So if you want to hire more people, you spend more money on it. So what we really focus on how to manage the time. We sometimes will also talks about how to manage the trade-off between the waiting time and the money cost. And if you just want to open you just want to hire one more import, it's really easy for you to calculate the values, the values you can save time. But if it is actually considered for the customer sides, it will be more difficult because different people may have different perspectives. They may have different thoughts, comments about their waiting. So it's really difficult for you to value their time. And when we mention waiting, so one of the important variables we need to focus on is the arrivals, so the number of arrivals. And in most of the situations, actually, as a manager, you can control the customer arrivals. You can control the arrivals via show lines, while providing the specific hours or some special stuffs over there. And as well as you can affect the service time as well. Service time is also another variables we care about. So you can just use the faster or slower servers to change the service time. So these two things, the variable the number of arrivals and the service time actually are the two important factors when we manage the waiting in process. So in detailed, you can apply the following strategies to help you to control arrivals. For example, you can group the customers into different categories. Some of them may be you can just spend less time on serving them. For example, for the Walmart, they have the self-checking out the lines for people who bought the items less than 12. So this is kind of can help you to segment the customers. You can also train your servers to be friendly, which may help which will be very efficient to impact the customers, let them feel the waiting is not that too long. As well as you can just give the information for the customers who are waiting for serving about the expectations waiting time, let them know how long they may wait, as well as to distract the attentions. like provide some free snacks, beverages, like provide free TV shows, the music, to like all other entertainment to help distract them. Or you can just like encourage customers to come back, come nature, like during the snack time. So this is kind of like some strategies you can apply to control the arrivals. And this is the first part I'd like to introduce for you before we learn more details about how to manage the waiting line problems. Now, let's talk about the second subtopic. So, what are the major components of the queuing system? And when we talks about managing the time in process, managing the waiting line problems, what we focus on. And we can divide them into actually three parts. So we can consider the arrival, we can consider like the processing systems, as well as the exit. So briefly speaking, this is all the things we focus on when customer arrivals, when they were served, and when they exit. And when we talk about arrivals, we will focus on the 5 factors here. So the first is about the population. And we have 2 different types of population. We have finite population, which is the limited size, like you have 6 customers, or you have like 8 or 10, whatever the numbers it is, it's kind of small group and it's limited. Or we have the infinite population. So it's kind of like it's so hard like to count the number of the customers, the number of arrivals. And actually, we don't have a specific number to distinguish, okay, this is the finite population, this is the infinite population. For the finite population and infinite population, one of the way we can distinguish them is like we consider the impact when 1 or 2 customers or the arrivals leave. For example, like we consider for like the equipments, like if you have 6 equipments, we regard that equipments as the customer. If you have like 5 or maybe 10, then if one of them is broken, it will impact a lot for your production. But if you have 1,000 or maybe 1,000,000, maybe 10,000, then one of them is broken, which will not have that big impact on the whole process. So this is also like why we need to focus on the population factor as well. So we need to analyze like what kinds of impact it may happen if 1 or 2 like kind of like the customers leave the pool. So this is the populations. We have finite and infinite. And the second factor of arrivals we need to focus on is about the distribution. So we may have a constant arrival distribution, which means like for any certain time, you have exactly the same number of arrivals. For example, like for any 1 hour, you have 6 customers. Then like for 10 to 11, you have 6 customers. For 11 to 12, you have 6 customers. And for 12 to 1 p.m., you have 6 customers. The number is certain, so it's stable. It will not change. This is what we call constant arrival distribution. But we know that actually most of the situation, like in reality, the number of arrivals are variables, are random. So if it's random, we can consider the 2 distributions here. In most of the situation, they may yield with exponential distribution or Poisson distribution. So these 2 distribution we use, this is kind of like statistical tools we use to analyze the probabilities of arrivals. So the differences is exponential distribution. We focus on the time. We focus on how long you may wait or how long like for the next customer arrival. So we focus on the time. While the Poisson distribution, we focus on the number of arrivals. So we focus on, okay, for the next 5 minutes, how what is the possibilities we may have 5 customer arrival? Or for the next 1 minute, what is the possibilities we may have 2 customers arrival? So we focus on the number of arrivals. So this is the differences between these two. But this is kind of like they are actually you can choose either of them, or you can choose both of them. It depends on what kind of aspects you focus on. So the figures here is actually the exponential distribution. So we consider the time. So means like how long like for the next customer's arrival. While these figures here, like we analyze the Poisson distribution, like we take a look about the probabilities about like the number of arrivals during time t. And you can see that the distribution here for the Poisson is actually discrete. So it's not continuous because like we analyze the probabilities of the number of arrivals. So the number of arrivals are integers. So we will not consider like 1.5 people arrival or maybe 2.3 people arrival. We always consider the integer numbers. So that's the reason like why it looks like discrete here. And for the exponential distribution, we can use this function. So while the e is actually a constant number and the number represents the number of arrivals, like in general, the average numbers we know, while we can use this function to represent, to get some numbers about the probabilities of the number of arrivals. The number here is still the number of arrivals, and the n factorial, this is actually equals to n times n minus 1 times n minus 2 until 1. And e is still the constant numbers here. Depends on the distribution. And how to use them. For example, for the exponential. The exponential here, like if we know, this is actually examples for the textbook, so you can find more details for the textbook. And for this specific example, the lambda equals to 5. So we know that's like for any minutes, like we probably have 5 customer arrival. This is kind of like general numbers. And we wanted to know like how long will the next customer may arrival. So then we just like give the t numbers here 0.5, which is 30 seconds, 1 minute, 90 seconds, and 2 minutes. And this second columns here means the probabilities that the next arrival will occur in 0, which means the t here, the 0 minutes or more. So it means like, okay, if you need to wait for more than 0 minutes for the next arrival, the probability is 100%, because we know like right now, the next customer hasn't arrived. So it's 100%, like right now we don't have the next customer. So the 0%, the third columns here means like the next arrival will occur less or in 10 minutes. So it's 0. And then the second, so 0.5 minutes, which are 30 seconds. It means like for the following 30 seconds, you have kind of, 61%, like your customer will not arrive, which means you have 39% that in the next 30 seconds, you will have the next customer. And this is also like 1 minute means like the probabilities of the customer will not arrive, like you need to have to wait for more than 1 minute for the next arrival is 37%, while like on the contrast, which means like you have 63% in a minute you will meet the next arrival. So this is how we use exponential distribution. We consider the time, while the second examples here we consider Poisson, and it's also we analyze the probabilities for arrivals, but we focus on the number of arrivals. And for this function here, like we know that the number is 3, so we know that's like the average arrivals is 3, and we consider for the next 1 minute, and the n equals to 5. So which means like we analyze the probabilities for the next minute if we have 5 customers. So the 0.101 means the probabilities like for the next 1 minute you may have 5 people, you may have 5 arrivals. It means it's probably 10%. So 10% for the next minute you will have 5 arrivals. This is how we use Poisson distribution, like we focuses on the probabilities of the number of arrivals. And note that there are actually 2 ways to looking at the same random variable. So it means like they kind of like not a constant arrival distribution, is kind of a random distribution, and we just like focuses on the different aspects while we use the different distributions here. Okay, so this is the second factor we consider for the arrivals, the distribution. And except for like the population distribution, we also have another 3. How the pattern, so if it is countable or uncountable. So if you still remember the first parts, like when we talked about what waiting line problem is, like I mentioned, like we actually as a manager, we have a few ways to control the arrival. But some of the surveys process actually we cannot. Like for most of them, it probably are controllable, but for some of them, like the medical emergency is uncontrollable. So when you decide like the models to help you to manage your waiting process, this is also another factors you need to consider about in terms of the arrival. And well, and the next is about the size. So we consider like the size probably the single or a batch. Single here doesn't mean like number 1. It means like it depends on the smallest unit you consider. Like for eggs, most of situation we consider a dozen of eggs. So it's not 1 egg, it's 1,000 eggs means 12 eggs. So when we consider single or batch, it's not like number 1, it's actually considered the smallest unit. This is the things you may need to note. And also the patients. So we have the patient, we have inpatient. Patient means like we don't consider the behaviors. Okay, so we consider if the arrival wait for the serving. So if they, whatever they, how they behave, but if they still like staying in the line and waiting for the service, then this is what we call patient. And even like their behavior looks like they are so patient, but if they leave the line, it means like impatient. So for the impatient, we have 2 different types. One of them is kind of like their arrival, and they say, okay, this is a known line, so they just leave. Or they just arrival, and even they say it's a known line, they just like decide to, okay, let's wait. But after a while, they just feel, okay, now I don't have that too much time, so they leave. We have these 2 different types, but whatever the types it is, if they leave the line, they are not like into the system to be served. This is the impatient. And this is all the 5 factors we consider for the first part, arrival. So we consider population, distribution, pattern, size of arrival, and degree of patients. And the next thing I like to introduce is about in the system. So for in the system, we consider 3 factors. The first one is about the waiting lines and the servers. So we may need to consider about the length, the line length, and the waiting lines length, and well as the number of lines. So we have single line, we have multiple lines, And when we consider the length, we consider the capacity actually. Like for example, for the gas station, because of the space limitations, so we have a limited size for waiting in the system. This is what we call the limited capacity. This is the finite length. And for some others, like if you are waiting for like a new fashion items, you stay in the line, then you can just like go another like box. You can stay, I mean the line could be go through another box. This is what we call it, like they have the potential infinite length. So this is about the length and the number of lines. And when we talk about the waiting lines, like in the system, we also have some like the priority rules to serve. Like a very common one is first come, first served. And we also have others, like we may, for some service, they may serve the shortest processing time customers first. Or for some restaurants, if you can reserve like in advance, then you can skip the lines. Or like for some service, the emergency first, as well as like we may have some limited needs or others. So this is actually kind of the priority rules like we may have like to manage the lines. And the second factor for the system is the time. So when we discuss the arrival, we know like the arrival rate is important. It's an important factor. And now we talk about the system. So the service time or the service rate is important. And for the service time, we also consider two different. One of them may yield with reasoning, like sometimes you may need to spend 10 minutes. Sometimes this process like spends like more than half of an hour. Sometimes 5 minutes is enough. So this is what we call the variables. For most of the service provided by humans, they probably like the readily. But for some like the automation process, the service rates are constant. So every 1 minute they can serve one person. So you can imagine like for an hour they can just like serve 60%. It's constant. And but for the variable, the random service and time, so it could yield with exponential distribution as well. And we often use mu to represent the average service rate. So what does mean service rate? We need to compare with service time here. Service time is how long you need to spend to complete that service. While the service rate is like for a unit time period, how many you can serve. For example, if you need to spend 10 minutes to serve on average, like 10 minutes to complete that service, the service process, then in an hour, actually you can serve 6. So 6 is service rate, while 10 minutes is service time. So this is the second thing you need to aware, like we talk about the service time, service rate. The third factor is about the structures of line. So we have a few different structures here. So we may have single server with single phase or single server with multiple phase. The phase here represents like the different steps you need to go through to complete the service, while the single channel means like the server, the equipment, or kind of like the service provider. So this is kind of like the channel. So we also have multi-channel with single phase, multi-channel with multi-phase, or the mixed. So back to the slides, it gives you some examples for each structure here. So for single server, single channel, single phase, like the one person barber shop. So we have one server to serve one customer. And we only have that one step. You just like do the barbershop stuffs. And or we have some single channel multi-phase, like you only have less stops over there, but it's like have different process. Like for the car wash, like they need to give you the water, then give you the some materials to help you to clean, and then water again. So this is the different steps. So this one line multiple steps, this is what we call the single channel multi-phase. And we also have multi-channel single phase. Think about like the checking out, like for the Walmart, for the Smith, for any grocery stores you may have, like they may have different like the checking points, but it's only one phase, like one steps, you just check out. As well as the multi-channel, multi-phase, like when you do some like hospital admissions, like you need to check in, and then for the reception desk, you have someone to help you, and you need to wait over there, and the doctors like the see you, and then you check out. So they have different steps as well as the different servers you need to go through, and as well as the mixed. So this is about the line structures. Like you need to figure them out. You need to figure out which structure it is when you start to manage the whole process. And the last thing I like to introduce is about the exit. So the exiting the queue system. And when we talk about exits, we probably will have two potential scenarios. One of the scenarios is like it probably will become a potential like return to the populations of arrivals, or it just like leaves the whole company's service process. So we have these two. So if the customer may return, this is what we call recurring common cold case. Or if they have a really low probability to be reserved, this is what we call this one. And this is the last thing I like to introduce, like for all the fundamental concepts you need to figure out. So in sum, the first subtopic we just learned what is the waiting line problem is, and for the second part we discuss more components, the main components in the queuing system. So we discuss for the arrival in the system and exit. So when we talk about the arrival, we have 5 factors. We have the population, we have distribution pattern, size, and others. And when we discuss the system, this is what we just focus on, the line and servers, the service time, and the line structure. And when we discuss exit, we have 2 different scenarios after exiting. So this is all the things I introduced for the first part of the chapter.